Hello everybody, welcome to this first lecture of the statistics component of Sci 3402. So before I get into the main substance of this lecture, which will focus on going back over between participants analysis of variance, I just want to give you a bit more of a general overview of what we want to do with this part of the module. So what I really want to do is give you what I'm calling an integrated refresher on data analysis in the context of doing research. So in concrete terms, that involves giving you some revision of techniques such as analysis of variance and regression, things that you will be somewhat familiar with from previous years, but then leading into some newer material focusing on things like effect sizes and mediation, and also probably more substantively using a new statistical package called Jamovi rather than SPSS, and I'll come to Jamovi in a moment. So some things that I'm assuming throughout this lecture course, things that I won't be going back over, are things like basic statistical concepts like significance, variance, etc., and also some of the underlying assumptions of parametric statistics, things that you will have covered before, and I'm assuming that you have already as a platform for doing the sorts of things that we'll be covering in this module. So I won't be covering them in this module explicitly, and the assumption is that you have already got those as assumptions. Okay. So what do I mean by an integrated refresher on data analysis? Well, in some sense, it's going back over at least some things that you will have covered before in statistics modules, but giving it a little bit of a twist. Because one thing we're aware of is that statistics often gets taught and thought about in a way that feels a little bit disconnected from the actual substance, the real stuff that we're interested in when we come to study and research psychology. We've got all sorts of questions about the world that we want answered, and often, statistics seems to be a little bit of a sort of a sideline that's delivered and thought about separately from the things that we're more fundamentally interested in. Now, what I want to do in this module is to take statistics and put it back into the bigger process, if you like, of doing research, of finding out about the things that interest us about the world, the things that drive our curiosity, and the things that we need to know to understand human behavior. So putting statistics back into the context of doing research means that we're thinking about it after having revisited principles of research design, formulating research questions and hypotheses, and thinking about how we can address those in a study. And it's in that context that I think it's most helpful to think about statistics as a thing, a tool that is part of our toolbox, if you like, for finding out about those things that drive our curiosity. So again, a little bit more concretely again, what we'll be covering over the 5 weeks are firstly in this session, between participants analysis of variance, before moving on in next week's sessions to cover analysis in designs that have repeated measures aspects using mixed models. Then in week 10, there will be 2 sort of mini sessions, one of which will cover effect sizes, and the second of which will start to reintroduce regression. Then the week after that, we will be carrying on the theme of regression before moving into probably the newest material in the module from your point of view, which is mediation and testing indirect effects between variables. So one of the things that I mentioned is that will be newer from your perspective in this module is using the statistical package Jamovi. So what is Jamovi? Well, it's an open source point and click program that's based on the R programming language. And 2 things that I think really recommend it for use in this module and in general. Firstly, I think it's very user-friendly, very intuitive, as you will see. And secondly, it is free. So it's absolutely open source, and it's available to you once you leave university, and it can be downloaded by anyone, anywhere who has a computer and an internet connection. It's also sort of crowdsourced by experts in statistics in the sense that it's it's constantly being updated in terms of its capabilities. So there are always new modules, new capacities being built into it that we can use. So it's a stats program that is constantly being updated, and yeah, sort of future-proofed, if you like. So again, another one of my assumptions is if you're watching this and going through this lecture series is that you are already at least a little bit familiar with Jamovi, at least in the sense that you know what it is and you've downloaded it. So if you haven't, and if you aren't, if you don't you have never encountered Jamovi, then I would recommend that you go back and have a look at this introductory video that I put together on how to start up with Jamovi. Okay, so if you haven't done so already, go and have a quick look at that, and then come back here and you'll be in a much better place to keep up with what we're doing in the rest of this lecture and the rest of the stats module lectures. A couple of other things I want to point you towards before we get going is on the LE page for this module. I've set up a number of other resources that might be useful for you. So these include YouTube channels, playlists, which cover basic and maybe more advanced statistical techniques by people like Andy Field and Brandon Foltz, and also has a link to last year's methods and statistics module, the LE page for that module. So you can go back over some of the stuff that you will already have covered, and also have a look into how other people address and cover and teach some of the techniques that I'll be talking about, but also head off into other things that they cover, which we don't have the time or space to cover in this module. On that note, I've also included a number of links to introductory materials for analysis techniques that won't be covered in this course, again, just because of lack of time and space. So these include things like exploratory factor analysis, moderated regression, so that's regression analyses that involve testing interaction effects in a similar manner that you might in analysis of variance. And then leading into structural equation modeling as well, which will follow on, I think, fairly nicely from the mediation lecture later in this series. The final resource that I want to point you towards, again, that is linked on the LE page, is the Improving Your Statistical Inferences online course. So it's what's called a MOOC, a massive open online course that's been put together by Daniel Lackins. Now it's completely free, it's available on Coursera, and it covers things such as how to interpret p-values. And again, I just want to emphasize the reason why you might want to look at that is the chances are you're maybe not doing it quite right just yet. It'll cover things like effect sizes and other approaches to analysis that are well beyond the scope of this lecture series. So things like Bayesian statistics as an alternative to p-values as a basis for inference, and also relating it to other broader topics to do with methods such as open science and replicability. Okay, so just going back to that sort of key sort of selling point, or the thing that I want to do with this module, putting statistics back into the context of doing research. With that in mind, if there's one sort of core message that I want you to take away from the module, it's that we need to think about, if we want to do research, if we want to find out about the world through empirical research, one thing we need to do is think about analysis, data analysis, right from the outset, not as something that maybe comes to mind as an afterthought once you've designed your study and collected all of your data and then start wondering about how to analyze it. Actually, no, we need to think about how we're going to analyze our data right from the start as a key part of the design process. So if we think fundamentally about what we need to test a hypothesis that we might have adequately, well, I think we need two things fundamentally. We need an appropriately designed study, a study design that's capable of addressing those questions. But secondly, if we have the data from an appropriately designed study, we also need appropriate analysis of those data. So what we will start to see is that, and a key message across the module, is that actually the way in which we as researchers going about testing and finding out about the things we're interested in, the design of studies is often actually explicitly about setting up particular forms of analysis, particular ways of analysing our data. We're thinking about how we're going to deal with those data right from the start as a key part of the design process. So we're thinking about whether, for example, there are manipulations in the design and how many, whether the independent variables or predictors that we have are continuous or categorical, and whether the dependent variables, the things we might measure as outcomes, also are continuous or categorical. And all of those, as part of the thought process behind designing studies, is also informing how we're thinking about analysing our data. So in terms of the options that we have, at least within the confines of this lecture series, some of the options we might have will be constrained by this assumption that the dependent variables that we're assessing are continuous. Okay, so it is, of course, perfectly possible to analyse dependent variables that are not continuous, categorical dependent variables, for example, but we won't be covering those techniques in this module. So an assumption underlying all of the things I'm talking about are our outcome variables, dependent variables are continuous. So with that assumption in mind, some other considerations are, firstly, how many independent variables do we have? And of those independent variables, are they categorical, for example? Are they perhaps manipulations of an independent variable, or categorical predictors like gender, or the school or the organization that people attend or work in? Or are those independent variables or predictors continuous? Are they measures of something like income, for example? A second key design aspect, a key consideration for analysis options is, are there repeated measures aspects to our data? For example, do participants contribute just one observation or one data point? Or do they complete the same measure at different time points? Or do they give scores on the same measure under different experimental conditions, for example? Do they provide more than one data point or observation in our analysis? Now, what I'm posing here as a rule of thumb, and I must stress it's a rule of thumb, not a law. So it's a rule of, it's a sort of a thing of convenience, a heuristic, if you like. That is certainly not set in stone, as we'll see a little bit later in the regression lectures. So, okay, with that caveat, the rule of thumb is for categorical independent variables, such as maybe manipulations in an experiment between participants, we'll be using an analysis of variance framework or mixed models. And for continuous independent variables, or if we have a mixture of continuous and categorical independent variables or predictors, then we'll probably be using a regression framework. Okay, so on to the main focus of this week's session, and that is between participant designs and using analysis of variance to analyse data from those sorts of designs. So again, as I said, between participants designs are designs in which participants contribute only one data point to each dependent variable. In experimental designs, for example, that mean that participants take part in one condition of several. Okay, so to get us going, one of the features and one of the things that I hope helps with that task of putting analysis and statistics back into the context of the research process as a whole is I want to talk about different analysis options as they relate to the different decisions we might make when it comes to designing our studies and operationalizing our studies. Okay, so what I'm going to do each week that I hope helps with that is I'm going to start with an overarching research question, and I'm going to look at how the different decisions or the different options we have in terms of designing a study that tests that in turn impacts on the analysis options that we have. So each time I'll start with a very simple design, maybe the simplest design possible that could test this research question, and then look at how, as we change features of that design, maybe make it more complex, how that in turn shapes our analysis options. Okay, so for this week, the overarching research question is, based on some of my own research, what is the effect of group status, the status of our group, on perceptions of intergroup conflict, the extent to which we see conflict or tension between a group we belong to and another group. So some of the thinking behind this might be that, well, if our group has relatively high status, we're motivated to protect the status quo, so there's no sense in rocking the boat and provoking conflict with other groups, so we tend to play down and perceive less conflict with other groups. Whereas if we have relatively low status, if we are at the wrong end of social inequality, for example, then perhaps we are more motivated to compete on behalf of our group and improve the status of our group. So we're more likely to see and perceive tension between tension between groups. So perhaps the simplest design possible to test that in experimental terms is let's just formulate a hypothesis first. So the hypothesis here might be that group members of a group will be less likely to perceive conflict with another group when our group, your group, the group you belong to, has relatively high status compared to when it has relatively low status. So a very simple, perhaps the simplest design possible to test that is a manipulation of that independent variable, in-group status, so that participants either belong to a relatively high or a relatively low status group. So we have two conditions, okay? A high status in-group condition and a low status in-group condition. And we measure perceptions of intergroup conflict using a self-report questionnaire. So two condition design, one independent variable and one dependent variable. As we'll see a little bit later on in this lecture and next week, with these sorts of designs, it's often very helpful to represent it schematically, okay, in terms of differences and contrasts between different conditions, okay, so a high in-group status condition and the low in-group status condition here, and what we expect might happen on our dependent variable in those conditions relative to one another. So here we're suggesting that we're going to see more of the DV, higher levels of the DV, perceived conflict, in the low in-group status condition compared to the high in-group status condition. So in terms of our analysis options, in this very simple two-condition between participants design, I'd say you pretty much have a choice between independent samples t-test or a one-way analysis of variance. So I'll show you how both of those might look in Jamovi. Okay, so I'm just going to bring up this example. So again, this is Jamovi. Here we have our data. So we've got in-group status, our data on the left here. In-group status, so participants are either in the low condition or in the high condition. And this is our measure of perceived conflict. Okay, so I'll run the t-test first. The t-test lives under t-tests and independent samples. Okay, so now we have this input window where we specify the model that we're going to test. So conflict is our dependent variable and in-group status is our grouping variable, our independent variable. Okay, so for reasons that will become clearer in the effect size lecture, I would encourage you to check effect size and confidence interval as well. Okay, and that's our t-test output. Now, in terms of analysis of variance, rather like SPSS, there are several different ways in which you can run ANOVAs in Jamovi. Now, the one I'm going to use, not least of all because it provides you the better platform for doing more and different and more complex analyses as you might want, is under linear models using the GAM-LJ module, which if you check back on the introductory video to Jamovi, that's a model that you will need to install via this command over here. Okay, but once you've got it, go to linear models and general linear model. Okay, so again, this is something that might look familiar if you're familiar also with SPSS. So again, our dependent variable is perceived conflict. In-group status is our factor, which is the name for categorical independent variables in this setup. Okay, so just put the output into the PowerPoint. So what we have here, first of all, is the t-test and the output from the analysis of variance. Now, the reason for showing you these side by side is to make a key point that firstly the p-values are identical, and there's also a mathematical relationship between the f and the t. Okay, so in any case, if you run a t-test and an ANOVA from an identical design, the t statistic squared will give you the f statistic, or if you have the f value, take the square root of that and you'll get the t statistic. So the key point here is that these different ways of analyzing it are functionally equivalent. Okay, and I guess one implication is that if you have a design like this and you're thinking, should I run a t-test or an ANOVA, you can run either, but there's not really much benefit in doing both, because one is redundant. You pretty much have the information that you need from one or the other. Okay. So analysis of variance comes into its own rather more for slightly more complex designs other than a two condition between participants one. So let's take that same hypothesis and extend it a little bit, add a little bit more nuance to it. So I've reformulated the hypothesis a little bit here so that it's now suggesting that group members will be less likely to perceive conflict with another group when their in-group has high or equal status relative to an out-group, okay, compared to when we have low status. So now with the hypothesis stated in these terms, a study design might manipulate in-group status not to have two conditions, high versus low, but to have three conditions, high and low, but now an equal status condition in the middle. So a three condition design. So looking something like this, schematically, the hypothesis is that perceived conflict will be greater in the low in-group status condition relative to the high or equal status conditions. Here, our analysis options are again a one-way analysis of variance, and with this sort of design with more than two conditions, this gives you an overall test of the effect of the independent variable status, but it also allows you to look at or test specific comparisons between individual conditions or combinations of conditions. Okay. Now, just in terms of how to do that in Jamovi, that last bit of looking at contrast between pairs of conditions or sets of conditions, under the factors coding drop-down part of the menu, you can change how your independent variable, three conditions in this case, status, how that's coded. So the default is simple or pairwise coding, but it's also possible to choose a number of other options. And the one we want here is called Helmert coding, because that asks for contrasts of the low status condition versus the equal and the high status condition combined, and then in turn for the equal versus the high condition. And it's this one here, low versus equal and high, that was pretty much implied by the hypothesis. Okay, so let's have a look at that in action. Okay. Back to Jamovi, and I am going to linear models. This is a different data set, by the way. So just to say, in-group status now has a low condition, high condition, and an equal condition. So again, we're back to linear models, general linear model. Again, conflict is our dependent variable, and in-group status is our factor, our independent variable. Okay. So we'll see here that, again, as I said, the default is for in-group status to be, just ask for simple coding for pairwise comparisons. So we'll see here this, this table in the output is giving you a comparison of the equal versus the low condition and the high versus the low condition. Okay. What we want to do to test that hypothesis is change that to Helmert coding. Okay. So now it's giving us the test of the low condition versus the equal and the high, and then the equal versus the high. And just to see what that means in terms of the contrast weights of these comparisons, you can check this box here, contrast coefficients. And that confirms that that first contrast, okay, low versus equal and high, is contrasting the low condition with the equal and the high conditions, which have the same contrast weights. Okay, and then in turn, the equal versus the high compares those, 0.5 versus minus 0.5, while ignoring the low condition, which is coded as 0. Okay. So just the key features of the output now in close up. Overall, there is a significant effect of in-group status. Okay, so this is the overall ANOVA table, the overall effective status. And that contrast of low versus equal and high, however, was not significant. So the difference between the low condition and the equal and the high condition combined was not significant. So there's our t statistic and our p-value. Okay. And just another thing that I've asked for under descriptive statistics in Jamovi, which I will, I'll show you how to do that now. So I just go back to that example. To get descriptive statistics for this, you can ask for estimated marginal means. Okay, gives you a quick overview of the means. But if you want the means and standard deviations, go to exploration and descriptives. Okay. Conflict is the variable that we're interested in, split by in-group status. So we want the means divided up by status. I'm going to pare back a few of the statistics that it's giving us. Okay, I'm going to change it from variables across columns, which is a bit less intuitive, to variables across rows. And here you can see the mean for the low status, equal status, and high status conditions, and the standard deviations associated with them. Okay, so that's how you can look for a nice summary of descriptive statistics using the descriptives function. Okay, so that's one-way analysis of variance. Now, of course, though, a lot of the things that we're interested in as psychologists, people interested in human behavior, is that, of course, human behavior is often very complex. And we know very well that the things that we're interested in are very complex in terms of the things that predict them. Often we're interested in more than one factor that might affect the stuff that we're interested in, the outcomes that we're interested in. And indeed, the theories and hypotheses that we often deal with often, or typically, in fact, specify more than one independent variable that will affect our dependent variable. And more than that, it also suggests that those independent variables might affect the impact of one another. So it might specify, for example, that the effect of one independent variable on an outcome will depend or change as a function of another independent variable. And that's what's tested by an interaction effect. Okay, so specifically, an interaction effect tests whether the effect of one independent variable is different at different levels of another independent variable or independent variables. Okay, so let's make that a little bit more concrete in terms of our research question. So let's go back to this basic proposition here. Group members will be less likely to perceive conflict with another group when their in-group has high status. Okay, that was our initial hypothesis, the most simple one. But now let's add some contingency here. We only think that this will be the case, however, when participants believe that their responses are going to be seen by the members of that other group, by an out-group audience, compared to when they believe that their responses will only be seen by members of their own group, in-house if you like. Okay, so now this hypothesis is implying not just one but two independent variables. We have status, as we saw, high versus low, but we also have audience, the audience to which we think, or to whom we think our responses are going to be directed. And we can manipulate that to have two levels as well, an in-group audience or an out-group audience. And the key thing that this hypothesis is suggesting is that the effect of this first independent variable status will in turn depend on levels of this second independent variable. In other words, a prediction that's drawn from this hypothesis is an interaction effect. Okay, there will be an interaction between status and audience. Okay, and again, I think this is where representing these designs schematically can really help. Okay, so this is our 2x2 design represented schematically. So we've got the effective status here, high versus low, but we're also breaking that down now by audience condition, in-group versus out-group. And it's suggesting here that perhaps we won't see much of an effective status in the in-group audience condition, but we will in the out-group audience condition. So our analysis options here are now a two-way analysis of variance. Now just to make clear, when we're talking about one-way or two-way or three-way analysis of variance, or one-way or two-way or three-way designs more generally, the number at the start there, the 1 or the 2 or the 3, that refers to the number of independent variables in the design. Okay, so we have 2 independent variables here. So we have a two-way design, which we will test or analyze using a two-way analysis of variance. Okay, so a two-way ANOVA gives you 3 effects, tests 3 effects. Firstly, it tests each of the main effects of the independent variables. So the effect of one IV collapsed across levels of the other. So the effective status collapsed across levels of audience, and the effective audience collapsed across levels of status. But it also tests the interaction between those independent variables. So it tests the extent to which the effect of, say, in-group status is different depending on audience. Okay. So let's look at a two-way ANOVA in action in Jamovi. Okay. Back to our original data set. So back to linear models and general linear model. Okay. So conflict again is our dependent variable. In-group status an independent variable, but also audience now is our independent, a second independent variable in the analysis. Okay. There's our output, appears very quickly. So I'm just going to talk you through the first part of that. All right. So key bits of the output. First of all, the main effects, the 2 main effects of status and of audience are both non-significant, but the interaction between them is significant, and that's how you would write it out in APA format. So this interaction is suggesting that although there isn't an overall effect of in-group status, it does seem to have an effect that in turn depends on or is different as a function of levels of in-group audience. Okay. Now, the next thing we're going to do after a quick break is look into how we can do some further analyses to interpret that interaction. Okay, so yeah, join us again for part 2 where we'll be picking that up.